in the previous video, I showed you the quotient rule, this rule here, meaning that if you want to differentiate one thing divided by another thing, you have to do this whole thing here. So in this video, I'm going to give you an example. Let's say you've got y equals blah 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 here. Differentiate y. Well, when given this here, find dy by dt. Normally, well, if you look at this as dy, if you look at this as dy by dx, what that means is normally our graph would be y and our graph would be x. So we would have something like this. So if you want to find out the gradient, you would get dy divided by dx here. This is your dx. Well, in this case, it's the same thing really. We've got a graph y here, but instead of x around here, it's t. So it could be this here could be time. So we would use t instead of x. It could be anything. It could be anything. So here it's really dy here divided by dt here. So it's really the same thing, but because I'm using t here, we are differentiating it with respect to t. Well, in this case, we are finding dy by dt. Okay, so well, anyway, given y equals blah 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 here, find dy by dt. Okay, so to do this here, to do this here, visualize as one bubble here divided by this bubble here. So this is like your u here, and this here is your v. So you start out by saying let u equals this and v equals this. So so then you would use this formula here. Okay, so hang on. So if you look at the quotient rule, hang on. If you look at the quotient rule, it's saying, well, don't forget this here is u and this here is v. So we are trying to differentiate u over v. Now to find the derivative of the whole thing here, keep v the same. So look at v here. This is v here. It's saying keep v the same. So that's us keeping v the same here. So that's us keeping v here. So it stays the same. And then concentrate on finding du by dx. In this case, it's us finding du. In this case, it's us finding du by dt. It's just us changing the t and the x around. So basically, keep v the same, okay, but then differentiate this thing here. And when you differentiate this thing here, it would be 6t. Okay, so when you differentiate this thing here, so you got to try and differentiate this thing here. So that would give you 6t. Now looking at this here, keep u the same, meaning, hang on, keep u the same, meaning keep this the same now. So so that's this thing here, and then concentrate on differentiating the v. So when you differentiate this v, it will give you 20t to the power 4. So keep u the same, that's this thing here, but then times this thing here, which is this thing here, which is this thing here. Okay, it's basically you following the whole thing here. It's telling you what to do. You're just blindly following it. So now now v, well, at the bottom it would be v squared. So v, this is your v here, and then square it. So looking at this here, this is your v and squaring it. So basically it's just you following this whole thing here. That would take you to this here. Okay, and now it's just a matter of tidying up. So if you tidy it up, this times this and this times this, that would give you these two. And don't forget you've got a minus here, so be careful. This times this, and don't forget to take the minus into account. That will give you this, and then this times this here. Don't forget to take this minus into account. That will give you this, and then it's just a matter of tidying up. That will give you this. Now so your dy by dt looks like this. Okay, so when you plot a graph, it will look like this. So this is your this is your y-axis, and this is your t-axis. So So at the moment, this is a straight y equals blah blah. Now, if you look at the gradient graph, it will look like this. This is your dy by dt here, and don't forget this whole thing here. This whole thing here is this thing here. Okay. So when you try and plot this graph here, when you try and plot this on a graphics calculator, you have to plot it as another graph, as in y equals this whole thing here. But just bear in mind that your new y here represents dy by dt. Okay, but at the moment, I have to say, at the moment I have to say dy by dt equals this whole thing here, because I'm trying to communicate to you that this here is the gradient graph. But when you come to plot it on a graphics calculator, you have to use another function, or another graph, another line equals this whole thing here. So this the whole thing divided by blah blah blah. My point is that I have to use dy by dt here to communicate to you that this whole thing here is a gradient graph of this thing here. Okay. Well, but when you come to plot it on a graphics calculator, you have to say y equals this whole thing here. But then bear in mind that this here is a new y. It represents something else. Okay. Well, anyway, if you plot y equals this thing here, it will look like this. So this was our original graph here. Now, if you look at this here, the gradient seems to be 0 here, because it's flat. There's a point somewhere where the gradient seems to be 0. So if you now look at the gradient graph, so at this point here, it seems like the gradient 0. So if you look at this, if you look at the graph, the gradient graph, hang on. If you look at the gradient graph, hang on. If you look at the gradient graph, it would look like this. You see this point here, it is 0. The gradient will be 0. Okay. Hang on. Let me show you what I mean. This was our original graph. If you look at this point here, think in terms of the gradient. The gradient at this point here is flat, so it's the gradient 0. Now let's look at the gradient graph. You can see that the gradient is 0 when you look at the gradient graph. Okay. Let's look at our original graph here. You can see, well, this point here happens, well, the gradient at this point here happens to be 0. Now, if you look at the gradient graph, it seems to be 0 here. Okay, and then if you look at if you flip back and forth, the two graphs actually correlate with each other. They actually make sense. For example, if you look at this point here, you see the gradient here is negative, and it's not that steep. The gradient here is negative, and it's really steep. Okay, it's really steep. So if you look at the gradient graph, hang on, the gradient graph, you see at this point here, the gradient, yes, it's negative, but come this point here, the gradient's really well, the gradient's negative, and it's really big negative, if that makes sense. Okay, hang on, let me show you what I mean. Hang on. Looking at our original graph, at this point here, the gradient's negative, but it's it's negative, but it's not that steep. Here, it's negative, but it's really steep. Now, looking at the gradient graph, it's negative, and it's quite steep, and around here, it's negative, and it's really steep. Okay, hang on. Let's pick another point here. This point here, the gradient is still negative, and it's really big. Now, if you look at the graph here, you see the gradient graph is negative, and it's really big. Okay, hang on. Let me flip back to this one here. Now, if you look at this point here, it's negative, but it's quite shallow. So when you flip to the gradient graph, at this point here, you see it's negative, and it's only around about 0.2, somewhere around there. So the two graphs actually they actually make sense. Okay. Well, anyway, given y equals this here, the dy by dt is given by this thing here. Okay.